The for loop. The while loop is good, but it is quite a bit of typing. The for loop does the same thing, but in a much more compact way. Neither one performs faster or better than the other. Here is the form for the for statement. Notice that all three requirements of a while loop occur within the parentheses of a for loop. The variable is initialized and only happens once before the loop begins. This variable is also referred to as a loop control variable. The condition is checked before the loop runs each time, as like before with the while loop. And the last part is the change in value that will occur to the variable at the end of each run, otherwise known as iteration, of the loop before being tested again. The following for and while loop are almost equivalent. Here we have the while loop. First, we declared our counter variable I, and that goes right here. Then here is the condition, while I is less than 10, I is less than 10 goes right here. And then finally, instead of having to write I++ in the body of the code, we have it right there. So you can see that this is a much more compact version of this. Variables declared in a for loop are only defined within the loop and only exist within that loop. This allows them to be reused. The following example shows two for loops, one after the other. The second can use variable I again. Let's see why. If you want to reuse the variable I with multiple while loops, you would have to reset I equals 0 after each loop. You do not declare it again, only use int the first time you declare the variable. This method might be confusing and is not recommended. So here you can see we declare int I equals 0, and then in order to use I again, we have to reset I to 0, but this is not recommended. The scope of a variable refers to the sections of code that can use it. When the initialized I is used within a for loop, the scope of I is only inside that loop. Other code outside the for loop can't see that specific variable I, hence why it can be declared, initialized, and used again. In this example, I in the first for loop is a totally different variable than I in the second for loop. This is legal because each variable only exists inside its own loop. So the scope of this I is inside these curly braces, and the scope of this I is inside these curly braces. The code below has a compiler error because once the computer leaves the loop, which is the scope of I, it forgets I entirely, as if I never existed. So here we declare I equals 0, we use it in this loop, and then out here we try to print I, but that's not allowed. Practice with for loops by identifying what would be printed below. Let's walk through this code together. We enter the loop and I is set to 5. As long as I is greater than or equal to 0, we can start the iteration or one run through the loop. At the end of the iteration, I is decremented by 1. The first time through the loop, the computer prints 5, and the value of I is changed to 4. The second time through the loop, the computer prints the new value of I, which is 4, and then the value of I is changed to 3. This continues with the computer printing 3, 2, 1, and 0. Once the computer prints 0, I has a decrement of 1. Then, when the computer tries to run the loop again, the condition is false, because -1 is not greater than or equal to 0. So the loop ends. The output for this program is 543210. Note, an off by 1 error occurs when a loop iterates 1 extra time or 1 time too few. What is the output? This loop is very similar to the last example, except this time I is initialized with a value of 10, and the condition is I is greater than or equal to 1. Therefore, during the first iteration, the computer prints 10, then 9, 8, 7, all the way to 3, 2, 1. Once the computer prints 1, I is decremented to 0, the condition is now false, and the loop is exited. What is the output of the following code segment? This loop initializes I with a value of 3. The loop will continue as long as I is less than 10, and I is incremented by 3 each time. When we enter the loop, I is 3, which is less than 10, so we continue. The computer prints 3, then 3 is added to I, giving I a new value of 6. On the second iteration, 6 is less than 10, so we continue. We will continue from the last slide. Alright, so the computer prints 6, then 3 is added to I, giving I a new value of 9. On the third iteration, I is 9, which is less than 10, so we continue. The computer prints 9, and then 3 is added to I, giving I a new value of 12. On the fourth iteration, the condition is no longer true, therefore the loop is exited, and we have an output of 3, 6, 9. Loops that count are very common and popular, but Java allows many possible kinds of loops. The following for loop starts with 1 and doubles each time. Notice the expression that doubles the variable, I, and then we have the multiplication sign and the equal sign, 2. Can you identify the output of the loop? 1, 2, 4, 8, 16. You can see that the variable I doubles each time. Can you identify the output of the following loop? Alright, so we begin with an I value of 2, which is less than or equal to 100. So we start the loop. We print the 2, and then the value of I is changed. First we multiply it by 3 and then add 1. Therefore the new value of I is going to be 7, which is less than or equal to 100, so we continue. We print the 7, and then we continue this 2 more times to get 22 and 67. However, after this iteration here, the condition will no longer be true. So our output is 2, 7, 22, 67.